So we're going to be talking about polygons and classifying polygons, looking at their sides, the number of vertices they have, the types of vertices they have. So there's a lot of information that needs to be looked at and included when we are talking about classifying polygons. So first of all, what is a polygon? Well, a polygon is a closed shape. So that means that it cannot be open. It says it is exactly what it says. It has to be a closed shape. So if I have a shape like this, that is a closed shape, meaning it is connected. If I have a shape like this, that is not a closed shape. It's open. Therefore, it is not a polygon. So there's lots of different polygons, and most of the times we classify them based on the number of sides. The number of sides tells us the name of the polygon. So if we have a shape that has 3 sides, what's the name of that shape? Triangle. Very good. And tri tells us 3. If we have a shape that has 4 sides, quadrilateral. Quad tells us 4. I always think about the quad that I ride around my property. 5-sided shape. That is a pentagon. 6-sided shape. Hexagon. Okay, 7-sided shape. Drawing a blank right now. Maybe you guys can look it up after and let me know. 8-sided shape. Octagon. Like an octopus. And I'm going to stop right there. We can go on and on and on. And a lot of, depending on the number of sides that it has a different type of name. So I've kind of touched on naming polygons based on the number of sides they have. But now let's focus on different types of triangles. So there are 3 different types of triangles. There are acute triangles. There are obtuse triangles. There are right triangles, and these are actually relating to the types of angles they have. Then we have equilateral triangles, and we have isosceles triangles, and we have scaling triangles. So equilateral, look what's in there. Equi, that means the equal lengths, equal length sides. So these are the sides, and these are the angles. That's the abbreviation for angles. So equilateral, equal length sides. Isosceles, that means that 2 sides are the same. Scaling, what do you think that means? If equilaterals, equal length sides, isosceles, 2 sides are the same length. Scaling means all 3 different lengths, different length sides. Okay. And then back here up to the angles. Acute, a triangle that has an acute angle smaller, which acute means less than 90 degrees. Its main one, this is actually an acute equilateral because all 3 sides are the same length and it has an acute angle. Obtuse. An obtuse triangle would mean that it's got an angle that is larger than 90 degrees, larger than a right angle. So that's an obtuse triangle. Is this an obtuse equilateral? Is it obtuse isosceles or obtuse scaling? Now my drawing's not perfect, but if I add this little guy here and this little guy right there, those two lines, what does that tell you now? That tells you that this side and this side are the same length. So if two sides are the same length, that means it's an isosceles. Therefore, this triangle right here is an obtuse isosceles. So what if I was to draw a right triangle? I know that this has a right angle because of this notation right there. So this is a right triangle. What if I drew this and that? What do we now know? This is a right isosceles. Two sides are the same length. Can we have a right scaling? Does that look like a right scaling? These two sides are different lengths. That's a different length, so therefore it's a right scaling. Can we have a right equilateral? I don't know if we can. I'm not sure. I think this is always going to be a different length than these. That's the hypotenuse of the triangle. So I don't believe it's possible to have an acute equilateral, a right equalateral. So we have acute, obtuse, and right angles. Acute is less than 90. Obtuse is greater than 90, but less than 180. So I'll write this down. So acute is less than 90 degrees. Obtuse is less than 180, but it's greater than 90. And a right angle is equal to 90 degrees. Okay, so that was my acute, my obtuse, and my right. Then we can look at different types of quadrilaterals. So a quadrilateral has how many sides? As we mentioned up here, it has 4 sides. So one kind of quadrilateral that I could have, which everybody is very familiar with, and I'm going to notate it like this. This type of quadrilateral has all 4 side lengths equal. It has 4 right angles, and this is called a square. So 4 right angles and 4 equal sides. It also, something about this, because it has those 4 right angles, all of those sides it has 2 sets of parallel sides. So this side is parallel to that side, and this side is parallel to that side. So it has 1 set of parallel sides and a second set of parallel sides. What if I have this shape? This also has 2 sets of parallel sides. Actually, I should keep it like this because this tells you that they're all the same length when they're all notated the same. And this one, these are notated the same, therefore they're the same length. Those are notated the same, therefore they're the same length. So this also has 2 sets of parallel sides, and it has 4 right angles, but 2 sides are the same length and the other 2 sides are the same length. That is called a rectangle. So it has 4 right angles, and it has 2 sets of parallel sides. And actually, let's do the notation for parallel for you to learn. Parallel sides. 2 sets of parallel sides. Okay. And then we have another type of quadrilateral. We could have, it has one set of parallel sides, and it does not have any right angles. So what is this called? This is called a trapezoid. So trapezoid has one set of parallel lines, but it doesn't have any right angles. It has, this is an obtuse, and this obtuse is the same as this obtuse, and this acute is the same as this acute angle. Then if we have a what looks like this, so this now has two sets of parallel sides, but it does not have any right angles. This is called a parallelogram. So a parallelogram has two sets of parallel sides, and it also has two obtuse angles, which also measure equivalent to each other, and two acute angles, which also measure equivalent to each other. But this time they are kitty corner. See that? They're across from each other, whereas these were right next to each other. So those are all quadrilaterals. What if we have a quadrilateral that has two sets of parallel sides, no right angles, and all four sides are the same length? So all four sides are the same length, two sets of parallel sides. What is that one called? It's called a rhombus. So a rhombus has two sets, parallel sides, and no right angles, or 90-degree angles, I don't know. No right, that's the notation for right angle. So no right angles. And I'm sure I'm missing something, but that is a lot of information for now.